I'm going to solve the same problem, only I'm going to use energy. Now, if you recall in the previous video, we got the acceleration was m2g, right? The weight of this guy minus the weight of this guy. And it was divided by 1/2 m1 plus m2 plus m3. Now, the trick I'm going to use is I'm just going to solve it, even though maybe there's no height. They might not give you a height. Just presume that it does fall some distance, right? And what we'll do is we'll figure out the velocity when it has fallen whatever that distance is. Now, remember that v squared is u squared plus 2as, right? If we let it fall some height from rest, right? Let's start from rest. Okay, if we let it fall some height from rest, then our velocity squared is going to be 2 times whatever that acceleration is times the height, right? Because this is 0 and then this is h, right? Whatever that height is. Okay, so therefore the acceleration is just simply v squared divided by 2h. So we'll set up an energy equation. When we arrive at v squared, all we have to do is divide by 2h, the presupposed h, right, that we made up, and we'll get the expression. We'll get this. We should get this. Okay, that's the strategy. So let's set up our energy expression. All right, the only energy we've got is, of course, the potential energy of this guy. Right, this guy's resting on the ground. This guy is above the ground. Right, so we just have m2 gh. Right. Now, when this thing strikes the ground, this guy will be moving down. This guy will be moving up, so there'll be kinetic energy, and of course this guy will be rotating, right? And this guy will be some height in the air. Wow, that's a lot of energy, right? So we'll have on the right side, we'll have the kinetic energy of this term, of this guy, the potential energy of this guy, the kinetic energy of this, and the kinetic energy of that. Now it sounds like a lot, but remember, this wasn't easy either, right? Okay, so let's just write these all down. So we've got, we're going to have m2 1/2 m2v squared, right? So that's this guy moving, right? We're going to have this guy moving as well, right? So we're going to have 1/2 I omega squared, right? Okay, then we're going to have this guy also moving, right? So 1/2, right? And then don't forget that this guy's going to be up in the air, right? We're all up in the air, right? So plus m3gh. Now, I guess you had to think of all those terms, but that's it. This is, physics is done. All we're going to do is math now, right? So potential energy of this guy becomes the kinetic energy of all three objects, plus don't forget this guy's up in the air now, right? We've got to lift that guy up, okay? And now we're going to do the standard substitution, right? So m2 gh is equal to 1/2 m2v squared plus, and then this thing is, of course, this is going to be 1/2 mr squared, right? And then instead of omega, we'll put v squared over r squared. Instead of omega squared, we'll put v squared over r squared, right? Plus 1/2 m3v squared plus m3gh. Okay. And then what I'm going to do 2 steps at once. I'm going to subtract this term from the other side because it doesn't have a v squared in it. So I'm going to say m2gh minus m3gh equals 1/2 m2v squared plus, and then 1/2 times 1/2 is 1/4. The r squareds, no surprise there, right? They go the way of the bison. So we'll go 1/4. Which m was that? That was, that's m1. 1/4 m1 v squared, right? Plus 1/2 m3 v squared. We're not quite there yet, but we are almost, right? Okay, so take a look at this. What I'm going to do is now let's factor out the v's here, right? So I've got m2gh minus m3gh equals v squared outside of 1/2 m2 plus 1/4 m1 plus 1/2 m3, all right? Now we're set. Drum roll, please, right? Okay, so we got v squared is equal to this guy here, right? So m2gh minus m3gh all over 1/2 m2 plus 1/4 m1 plus 1/2 m3. Now remember our trick. To turn v squared into acceleration, simply divide by 2h. So divide by 2h. This will become a, right? Now, all this h does is, of course, cancel those h's, right? And then if we multiply the denominator by 2, we get a is equal to m2g minus m3g all over, well, 2 times 1/2 is m2. 2 times 1/4 is 1/2. 2 times 1/2 is, there's no half there at all, right? Aha! Voila! If I invoke the commutative property of addition, and we can see that the denominator and numerator are exactly the same. Okay, I can plug these numbers in. I can get that acceleration. I could have used this expression before I divided by 2h and gotten the velocity. It all works. I'm going to say that energy is the bomb for this, right? Because really, our physicsing was this. We didn't have to worry about torque to the right, torque to the left, right? And I didn't have a system of equation. I didn't have to do fancy substitutions. I just had to realize that this potential energy turned into kinetic, 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 and potential, right? That's, I think, easier, conceptually easier. When you want to get an acceleration, just divide by 2h. You made up the h anyway, right? I mean, maybe they didn't even tell you that. They could just say, what's the acceleration, okay? I encourage you to use energy. Maybe try both, I don't know.